Okay, welcome back. Now, we have discovered that the area under any curve can be obtained using this, whereby if my curve was y is equal to fx, of course, this can be, like for example, the other curve we look at was a curve which would look like this. This was the curve y is equal to x squared. Okay? Assuming the curve is now y is equal to x squared. Therefore, it means the area under the curve will be equal to y is now x squared, which will give me x squared dx. Now, what does it mean? It means I'm now integrating this function with respect to x. Of course, this is the curve we are looking at. Now, remember that I tried to define this curve. For instance, I was saying that, let's say the curve, the area of my interest is between x equal to a and x equal to b. Okay? Now, these are called ordinates. They are called ordinates. Okay? Now, in other words, it is the boundary where I want to find the area. For example, now my A is become the lower ordinate, and B become the upper ordinate. So I will now write my area under this curve to be the area A become the integral from x equal to A to B of x squared dx. Now remember that these dx determine the constant A and B. When you are doing with respect to the x, that means this constant must also be in terms of x. Of course, as we shall see, we can also get with respect to y. Now, in this case now, if I'm to find the area under this curve, now it would be the curve and the x-axis. X is from x equal to A, x equal to B. Meaning now that I'm integrating or finding area within this area, this is A and B. Now, what does this one mean therefore? If I'm now to find the area of this curve, we say area A will become the area when I put the value of the upper limit, which is of B minus the area of ordinate A. So by doing this, I will find the area under this curve. So in other words, I'm going to remove part of this area from here, and then part of this area from here. The remaining part give me this area I want. This is area A now. Now, for example, now if I'm given this, let's look at this example. If I'm supposed to find the area between the curve y equal to x squared, and of course the limit is from x equal to A and x equal to B. So my integral will be integral of the area I want will be integral of x, which is A, and then this is B. For example, maybe x is 1. Let's say x is 1. B is 2. B is 2. So I'm finding from x equal to 1 up to that. So it means I will now say x is 1 up to 2 of x squared dx. Of x squared dx. Of course, I shall integrate usually. I will say x cubed over 3 plus c. Then I use this bracket. Then I insert the limit, this is 1 up to 2. So I find out the area A become, I put now this 2 where there is x, which gives me 2 to the power 3 over 3 plus c, then minus, where there is x, we put 1, this is 1 to the power 3 over 3 plus c, which gives me area A will become 2 to the power 3 is 8 over 3 plus c minus 1 to the power 3 is 1 out of 3. Of course, minus affect this minus, become also that. Which means this c will cancel. We'll have now area A become 8 out of 3 minus 1 out of 3, which gives me 7 out of 3. Now, you see what happened to the constant? The constant cancels. So that therefore means when you are dealing with integration with limits, there will be no need of putting the constant because at all times the constant will cancel. And this type of integration is called definite integral. We call them as being definite integral. Okay? Meaning that the limits are defined. So when we're dealing with this kind of integration, we deal what we call definite integral. But the other we did in the first time, which is open, is called indefinite integral. So this answer this integration. Now you look at the constant. So meaning if you have integration which has limits or indefinite integral, you don't need to bother putting the constant because at all time, if you result the limit, it will disappear or it will cancel. Thank you.